Hello everyone, myself Sravanthi, working as Assistant Professor in the Department of Cybersecurity and Data Science in MLR Institute of Technology. Today our topic is Finite Automata. So the overview is, what is Finite Automata, how to represent a Finite Automata, what are the Finite Automata models, and what are the types of Finite Automata. These are the topics we are going to discuss today. So initially, what is Finite Automata? So finite automata is nothing but it is a mathematical model that is used for computation, and finite automata is nothing but it is used to recognize patterns. It is a mathematical model that is used to recognize patterns. It takes the string of symbols as input and changes or transforms its state accordingly. When the desired symbol is found, then the transition occurs. So nothing but here there will be a string. That string is consisting of symbols, collection of symbols. So when a particular symbol is found, when a string of particular symbol is found, then the transition occurs. Nothing but it moves from one state to another state. That it means. At the time of transition, the automata can either move to the next state or stay in the same state. Either it can move to the next state, this is the next state, or it can stay in the same state. Same state is nothing but self-loop. Next state is nothing but one state to other state we are moving. That is the meaning. Finite automata have two states, accept state or reject state. I have given you one string. If that string is satisfied by using this finite automata, we can tell that the string is accepted. If that particular string is not found in according to this diagram or according to this finite automata, we are going to tell that it is reject state, not found. When the input string is processed successfully and the automata reached its final state, then we can tell that the string is accepted. So, the given string, for example, I have given you some string ABA. So, if I reach the string by using these finite automata, if I reach the final state, then I can tell that the string is accepted. If I am not able to reach the final state, that is nothing but it is reject state. So, finite automata is nothing but it is a mathematical model. It is used to recognize patterns, and we can check that whether the string is accepted or not. So, the formal definition of finite automata. Finite automata consists of 5 tuples. Finite automata consists of 5 tuples. The first one is capital Q, sigma, delta, Q naught and F. These are the 5 tuples. The first one is Q. Q points to number of states, nothing but set of states, collection of states. Sigma is nothing but set of input symbols which I am going to use in my transition diagram or in my finite automata. Delta is nothing but transition function. Transition function is nothing but if any input symbol is coming or if any input symbol occurs, either it is going to stay in the same state or it is moving to the next state. So that is nothing but all these things are stored in the transition function. The next one, Q naught. Q naught is nothing but it points to the initial state. F is nothing but final state. If I reach my string, if I complete reading my string, nothing but if I reach the final state, then we can tell that the string is accepted. If I cannot reach the last state, nothing but final state, we can tell that the string is rejected or not accepted. So these are the 5 tuples which we are going to use in our finite automata. So what are those? Q, sigma, Q naught, F and delta. So delta transition plays a vital role here. So for example, we are having, consider the fan is in on state. I am going to take one state that is nothing but it is in on state. And the next, when it is switched off, when the fan is switched off, so what it is happening? It is moving to the off state. When the fan is switched on, it is in on state. When the fan is switched off, it is moving to the off state. So, when it is from off state, when again if I switch on the fan, it is moving to the on state. So, nothing but, so from one state, it is moving to the other state when I find some input symbol. When I find one input symbol. For example, switch is there, fan switch. If I switch on, it is moving from one state to another state, it is moving. So that it means. So on state to off state. These are the 2 states I am having. From one state, it is moving to the other state. When I switch on the fan, it is moving to the on state from off to on. If I switch off, from on to off, it is moving. So this is the procedure it takes place. So the states are represented with circle. States are represented with circle. So states are represented with circle, and inside there will be a states. State names are going to be there. The next, input symbols. Input symbols are nothing but either anything A, B, C or 0, 1, anything. The symbols which we have learned in alphabets. So that all comes under input symbols. So starting state, initial state or starting state is nothing but the start state which I am going to have in my diagram. So that is nothing but initial state. The final state is nothing but how to identify. All the states are representing in a circle. So how to identify the final state? The final state is represented with 2 circles. So this indicates me that this is the final state. So here there are 2 states are final states. Okay, according to this example. So now how to represent a finite automata? There are 3 ways to represent a finite automata. The first one is transition diagram, nothing but graphical diagram. Next, tabular, transition table, mathematical. So transition function. Okay, so we can represent the finite automata as transition diagram or transition table and transition function. So we'll move to the first one. Transition diagram. So what transition diagram? Till now I have drawn with one example, that off and on state. So that is nothing but transition diagram. The transition diagram consists of states, inputs and initial state, final state and the transitions. So this is nothing but the transition diagram. See here. So what are the transition diagram consisting of? So there are 3 states are there. Q1, Q2, QF. These are the 3 states I am having. Q1, Q2, QF. Q1, Q2, QF. These are the 3 states I am going to have. So what is the initial state? Initial state is represented with arrow, but there is no input on it. There will be a edge, but there is no input on that edge. So that is nothing but initial state. Initial state points to the first state. So here what is the initial state I am having? Initial state is Q1. Initial state is Q1. Why? Because the starting state itself we are going to call it as a initial state. And how it is represented? It is a initial state. There will be a one edge with no input on it. There is a one edge. Look at here. There is one edge with no input on it. So how to represent a final state? Final state is represented with 2 circles. So see here, what are the states having final state? QF. So QF is my final state. QF is my final state. So what are the input symbols I am having? Input symbols. To move from one state to another state, there are some inputs are there. So what are those inputs? 1 is one input, 0. So the number of set of input symbols 0, 1 are the input symbols. See here, I have written intermediate state. Q1 is my starting state or initial state, QF is my final state and the intermediate is Q2 state. Same thing which I have written here. So the transition diagram is very much important to construct either a DFA or NFA. Next we are having this transition table. So transition table, the name itself it is telling that it is a tabular representation. We are representing it in the form of a table. So that takes 2 arguments. The table consisting of 2 arguments. One is pointing to state and the other one is pointing to symbol. And it is going to return some value. That value is nothing but the next state. I am having state. If I point one state with one symbol, either it can stay in same state or it can move to the next state. That it means. In transition table, the following factors are considered. Rows corresponds to state. Column corresponds to input symbol. See here, I am going to draw. Here these are nothing but states and these are nothing but input symbols. Entries correspond to the next state. I am going to point. If here one state are in there and one input. Q0 on 0. Either it is moving to the same state or next state. The state is marked with, the start state is marked with arrow. If the first state is nothing but how to represent whether this is the starting state or the final state, that is pointed with arrow. The accepted state, nothing but the final state, can be represented with star or circle. Both the things can be done. In a table, I can represent the starting state with arrow and the final state. For example, QF is my final state. I can represent the final state either with star or I can point this with circle. Both can be done. So this is the transition table. By using the transition table, we can construct a transition diagram. By using transition diagram, we can construct a transition table. Anything can be done. See here, there is one diagram, transition diagram. By using these transition diagram, we are going to construct a transition table. Here, how many states are there? There are 3 states, Q0, Q1, QF. I have written here, Q0, Q1, QF are the states. What are the inputs I am having in the transition diagram? 0 and 1 are the inputs. 0 and 1 are the inputs. Next, so Q0 on 0, Q0 on 0 input. See here, Q0 on 0 input. Q0 on 0 input. Where it is moving? Either it can move to the next state or it can stay in the same state. So Q0 on 0, where it is going? Q0, staying in the same state. Self loop is there. So Q0 on 0, Q0. Q0 on 1, Q0 on 1. Where it is moving? Q0 on 1 input. Where it is going? Q1, Q1. See here, this is nothing but the state and this is nothing but the input symbol and it is going for next state or same state. So this is the transition table. Current state, input symbol, it is pointing to some state, new state. Next, Q1, Q1 on 0, Q1 on 0. See here, Q1 state on 0 input, where it is going? QF, QF. Q1 on 1 input, Q1 on 1 input, it's staying in the same state. So nothing but self, Q1. QF on 0 input. Any 0 inputs are there for QF? No, it's not there. So nothing but nothing is there. So I kept blank. QF on 1 input. Where it is going? Self loop. So QF. So see here, the starting state. So this is my starting state. So starting state is represented with arrow. Starting state is represented with arrow. Here the final state is, how to identify which state is the final state? 2 circles. So QF is my final state. So QF is my final state. How to represent the final state? I can represent it with star or I can point it with circle also. So this is nothing but the transition table. To construct a transition table, we should have a transition diagram. Or by using transition table, we can construct a transition diagram. So to construct transition table, we should know the state and input and where it is moving, either to the next state or the same state. Same thing we have written here. 2 arguments are there. That is nothing but delta colon. This is the main thing. Transition table. Delta colon Q cross sigma tends to Q. Q cross sigma tends to Q. Q is nothing but, which we have seen, 5 tuples. The first one we are having is Q. Q holds number of states. What are the states I am having? Q0, Q1, QF. For all these states, I need to find the input symbols. What are the input symbols I have? 0, 1. For each state, I need to find these 2 input symbols. And for Q1 also, these input symbols. And for QF also same these input symbols. And we need to check whether it is moving to the next state or same state. Based on that, we are going to draw the transition table. It's clear? Next, transition function. So the transition function is nothing but delta is pointing to transition function. So current state, input symbol pointing to the next state. So same, the 2 parameters are mentioned below. Those are current state and input symbol. The transition function returns some state. That is nothing but next state. See here, current state, current input, it is moving to the next state. Same thing, delta of current state, Q cross sigma tends to Q, which we have written. The same thing we are writing here as Q comma sigma is equal to Q. Q holds the number of states. That's why we are writing here Q. So each and every state, for all the input symbols, we are going to check whether it is lying in same state or moving to the next state. So that is nothing but transition function. So the next one we are having is finite automata model. So the finite automata model consists of two types, input tape and finite control. So the input tape is nothing but, it is a linear tape. It looks like an array. It is a linear tape having some number of cells. Each one we are going to call it as a cell. Each cell holds single input symbol. It holds only single input symbol. Multiple symbols are not hold. Multiple symbols cannot hold by this input symbol, input state. So in each cell we can hold or we can have only one input symbol. The next one, finite control. The finite control decides the next state on receiving particular input. Nothing but this finite control holds all the delta functions, nothing but the transition functions, input state, final state. What are the things we are going to do in the transition? All those are stored by the finite control. Same thing, see here, decides the next state on receiving particular input from input tape. From these input tape, it is going to read each input by using the read tape from left to right. If I find one input, it points, it tells that it is moving to which state. So that all the things are held by finite control. The next one we have is tape reader, or we can also call it as read tape. Read tape, tape reader or read tape. Read tape is used to read each cell, reads the cells one by one from left to right. It reads each cell, one cell at a time from left to right. From left to right. So that input cell it reads and it holds by the finite control. This is nothing but finite automata model. So till now we have discussed what is finite automata. Now we are going to find what are the types of finite automata we are having. There are two types of finite automata. The first one is deterministic finite automata and the other one is non-deterministic finite automata. The deterministic finite automata we can tell it as DFA and the non-deterministic finite automata we can tell it as NFA. Deterministic finite automata, non-deterministic finite automata. These are the two types we have. So the next we are going to have what is deterministic finite automata. Nothing but what is DFA. So the DFA is nothing but the finite automata. If we find a finite automata, by default we are going to call it as a deterministic finite automata. If the machine read an input string, one symbol at a time. The machine reads one string, one input string at a time. Nothing but from the input string, one symbol. This is the input string. For example, I am having A, B, A is the input string. From these input string, the machine reads one input symbol, one symbol at a time. It reads one symbol at a time. In DFA, there is only one path for specific input from the current state to the next state. There won't be multiple paths for a single input. For one input symbol, only one path should be there for each state. So that is the main thing, main important point here in DFA when compared to NFA. So one more time, in DFA, there is only one path for specific input from the current state to the next state. To move from one state to other state, there will be of only one input symbol will be there. Multiples are not allowed. So the DFA does not accept null move. DFA cannot accept null move. Null is nothing but we are representing it with epsilon. Null moves are not accepted in DFA. The DFA cannot change state without any input character. Nothing but suppose see here Q0 is one state, Q1 is another state. So to move from Q0 to Q1, from one state to another state, I should have some input symbols. Some input symbols should be there. With empty input symbols, I cannot move from one state to other. Like epsilon. Epsilon is not allowed. So from Q0, I cannot move to the Q1 state by using epsilon. Nothing but by using null moves without any character. Without any input character. I cannot move from Q0 to Q1. This is not allowed in DFA. Epsilon moves are not allowed. DFA contains multiple final states. There is no rule that it should contain only one final state. We can have multiple final states. but only one initial state. It will have only one initial states, but multiple final states can be there. It is used in lexical analysis in compiler. This DFA is used in lexical analysis. We'll learn this topic in coming classes. So see here, one example I have written Q0, Q1. These are the two states I am having. So the two states, there are input symbols are there. See here, Q0 is having A input. On A input, it is moving to Q1. On Q0, on B input, it is staying in the same state. Q1, I am having two inputs, A comma B, both are pointing to the same state. Both are pointing to the same state. So this is nothing but DFA. So the formal definition of DFA. So what is the formal definition? So see here, just now we have learned the finite automata. The finite automata also consists of 5 tuples, and the DFA is also consists of 5 tuples. In these the 5 tuples, what are those the 5 tuples we are having? Q, sigma, Q0, F, nothing but final state, and delta. So these are the 5 tuples we are going to have. If we find a finite automata, nothing but it is a deterministic finite automata. Just now we have seen here. So the Q is pointing to the number of states, nothing but set of states. It is written in the flower brackets, and sigma is nothing but what are the input symbols I am having. Number of input symbols, for example 0, 1. Some inputs, some alphabet symbols. Q0 is nothing but starting state. It is pointing to the starting state. F is pointing to the final state, and delta is pointing to the transition function. Transition function is nothing but when one input occurs on one state, either it is staying in the same state or moving to the next state. So that it means that all the things are done by this transition function. The transition function, see here, delta, Q is nothing but current state, and sigma is nothing but input symbol. It is moving to the next state. Every time next state? No, there is no like that. So next state is nothing but same state or other state. Any state, it can move. So current state, 10 cross input, it is moving to the next state. So these are the 5 tuples we are going to have. The main point in DFA is nothing but for each input, some transition should be there. Some transition should be there only once. That is the DFA. Coming to NFA. NFA is nothing but it is a non-deterministic finite automata. Non-deterministic finite automata. When it is compared to NFA, this DFA is bit easy. When compared to DFA, this NFA is bit easy. So for a given regular language, the finite automata are called NFA when there exists many paths for specific input from the current state to the next state. Here in NFA, what we are going to tell, for each input, there can be many paths. Nothing but, for example, 0, 1 are the two inputs I am having. So Q0, Q1, Q2. These are the 3 states I am having. So on one input, I can have multiple paths. Nothing but, so Q0 to Q1 one path. Again I am pointing to Q0 to Q2 one path. And again I am pointing self loop. So multiple paths can be there for a single input. So that is the difference for NFA and DFA. In DFA, we will have only one path. Only one path. For each input, single path should be there. So that is the difference. And the other thing is, every NFA is not DFA. Every NFA is not DFA. But we can convert. NFA can be translated to DFA. Every NFA, we cannot tell that it has a DFA. But we can convert this NFA to DFA. That is possible. NFA is defined in the same way as DFA. But the only difference here we are having is 2 exceptions are there. We will have multiple next states and it contains epsilon transitions. So multiple next states are nothing but, see here, Q0 on 0, it is moving to the next state Q1 and it is also moving to the Q2 next state and it is also staying in the same state. Nothing but multiple next states are existing. And epsilon transition. Epsilon transition is nothing but when I have 2 states, I want to move from one state to another state with no input. So nothing but with epsilon is possible. I can move from one state to another state with epsilon in NFA, but that is not possible in DFA. These are the two exceptions which are differ from NFA to DFA. And the transition function is also differ here. Here the NFA is also consisting of 5 tuples Q, sigma, Q naught, F and delta. These are the 5 tuples we are going to have in NFA as well as in DFA. But the only difference occurs in the transition function. The only difference is in transition function. In DFA, the transition function is nothing but Q cross sigma tends to Q. Nothing but current state, input symbol and next state. This is for DFA. But coming to NFA, what we are going to have? Q cross sigma tends to 2 power Q, power set of Q. This is for NFA. So this is the thing which we are going to have. So this is the two differences which we are going to find in NFA and DFA. See, so these are the topics which we have discussed. What is finite automata? How to represent a finite automata? And what is the finite automata model? What are the types of automata we have discussed today? In the next coming class, we will discuss how to design a DFA with examples we will be discussing. Thank you.